Hello everyone, welcome back. This is my third video and I'm excited to continue our journey together. Let's start. Today's topic is the, oh my God, what's this from the first? Please go. Okay. General rules for the solubility and precipitation. Look, this is really important, okay? You will need this in chapter 1, chapter 2, chapter 6. Imagine, this is really important. So I will explain. We have around 6 to 7 rules. I will explain them in something very simple like mind mapping, okay? It will become a shed light really for you. So please try to draw the same thing that I will do right now, okay? It will become very useful, believe me. Okay, I will open a new page with the black background. I don't know if it's okay. No, black background. Okay, it's good, I think. Okay, the white color, it's better. Good. So rules for solubility and precipitation. First of all, water-soluble compound. For the water-soluble compound, I will say, or we will use the physical state of aqueous, and water-insoluble compound, we will use solids. Okay? Good. Assume that, first of all, these rules can be used for the prediction of the solubility for the ionic compounds. Be careful. For which type of compound? Ionic compound. So assume that we have X, Y as any ionic compound. It could be any ionic compound. Okay? So we have 4 rules. 4 rules. What is the physical state of the substance? If it's solid or aqueous. How do we know? For that purpose, we have 4 rules. As I said, we have 4 rules. So if you follow the following rules, you'll solve all the questions. Not most of them. All the questions. Look, rule number 1. Chlorides. Chlorides. Okay, check the formula. If there's some chloride or not. Okay, example, we have some compound that contains chloride. You will say most of them, look, most of them are soluble, except of, we have some exceptions. Except of, we have 3 chloride containing compounds that cannot dissolve in water, like the first one AgCl, the second one PbCl2 in cold water. Mister, what if the water is hot? It will become soluble, aqueous. And this, the third one Pb, okay. The third one, Ag2Cl2. Okay, these are solid compounds, water insoluble compounds. Okay, so chlorides, most of them are water soluble except of the following compounds. Let's have their names. Okay, look at this. The names are important. This one, silver chloride. Silver chloride, this one, lead. Oh my God, okay. Lead, II, chloride. And the third one, mercury with the charge of +1 chloride. Mister, how about this compound? If I say this compound, AgCl2. This is mercury chloride. This one is aqueous. Be careful, but this one is a solid substance. So chlorides, most of them are water soluble. Most of them are water soluble except of the following compounds. The first one, the second one, the third one. So if I say which of them is always water insoluble, Which of them is always water insoluble? Only AgCl and Ag2Cl2. But Mr. How about this? This is not always insoluble. There's a condition, the water must be cold, then this is insoluble. But if I say in hot water, it's soluble. It will become AQ. So if I say always, it means it doesn't matter if the water is cold or hot. Okay? So these are water-soluble substances by the following conditions. This is the first rule. Okay? So let me write the number of the rule here by the greater font, I mean. This is the first rule. The second rule must be here. Okay? Look, this is for the fourth rule. I'll leave this space because we don't need much more space for the last rule. The second one must be mentioned in there. Let's solve some examples related to the first rule. If I say, how about NaCl? Predict the solubility of this compound. Okay. Rule number one, chlorides. Chlorides, most of them are water soluble except of the following things. Is there any chloride? Yeah, Mr. We have chloride. Okay. So, is that a member of one of the following things? No. So this is AQ. Chlorides, most of them are soluble except of the following things. Okay. Rule number two. I will delete this part. I'll delete this part. Look. Rule number two. The second rule. The second rule. Sulfates. Sulfates. It means compound containing SO4 -2. Look. Mostly are water soluble again. Mostly are water soluble except of. That means we have the following compounds with the SO4 and they're insoluble. S. Okay? Look. SR, Ca, Ag, Ba, and Pb. Look. SR, SO4, Ca, SO4, Ag, SO4, Ba, SO4, Pb, SO4. These are water insoluble substances. Water insoluble substances. Be careful. Okay? So sulfates, most of them are water soluble. Most of them are AQ, except of the following compounds. Strontium sulfate, write the names. Okay, I'll tell you how to write their names. Strontium sulfate, calcium sulfate, Ag mercury sulfate, barium sulfate, and lead sulfate. Okay, these are water insoluble. How to memorize them? Look, Cirque. There's a nice phrase, Cirque, Ag. You can memorize Ag like my name, Hogr. Cirque, Hogr, Bapir. Or Cirque, Haji Bapir. Okay? Haji Bapir. Look. Sulfates, most of them are water soluble except of those that they came with the Cirque Haji Bapir. It means SO4 with SR, with Ca, with Ag, with Ba, with Pb, RS compounds. Okay? RS compounds. Again, SO4 containing compounds, most of them are water soluble except of the following compounds RS. Let me give you an example. An example of this, look at this. Al2SO4 by 3. Okay, tell me if the compound is S or AQ. Well, what's the first rule? Chlorides. Is there any chlorides here? Is there any chloride? No. Leave the first rule. Go to the second rule. The second rule is for the sulfates. Is there any sulfate? Yeah, mister. Here we have sulfate. What's the rule of the sulfates? If sulfate comes with the Cirque Haji Bapir, it will become solid. If not, it's aqueous. Okay? Okay, is that a member of Cirque Haji Bapir? No, so this must be AQ. Another one. BaSO4. Predict the solubility of this. Look, the first one, rule of chlorides. Is there any chloride here? No. Second rule, sulfates. Okay, how was the rule of the sulfates? Most of them are water soluble, except of سركة حادي بابير. سركة حادي بابير. Yeah, Ba, بابير, Ba. It's a solid substance. Good. Mr. What if there is no sulfate? We go to the third rule. Rule number 3. Rule what? Number 3. Rule number 3 is for the sulfides. Sulfides. Sulfides, S negative 2. Most of them are insoluble this time, except of. So sulfides, most of them are S, except of the following compounds. Look, CaS, K2S, Na2S, SRS, NH4 by 2S. Except of the following compounds, which are aqueous, all the sulfides are solid according to the grade 12th book. Be careful, not in the universe, in the book. Okay, look. First rule, check for the chlorides. If there's some chloride, we'll decide according to the following points. If we have the following compounds, it must be solid. If not, it's aqueous. Then, if there is no chloride, go to check for the second rule, which is sulfates. Most of them are water soluble, except of the following compounds, which are solid. If there's no SO4, go to check for the S. Most of them are insoluble, except of the following compounds. Okay, but how to memorize the following compounds? This time we have a nice phrase which is called Kak Nasr ammonium. Okay? So if we have S with the following compounds, it will become AQ. Example. Yeah, let me give you some examples. Here I will write the examples. If I say Al2S3, let's predict the solubility of this compound. Okay, go to check for the first rule. Is there any chloride? No, leave it. Second rule, sulfates. Is there any sulfate? No, leave it. Third rule, is there any S? Yeah, mister. Okay, how was the rule of the S's? Of the sulfides? Most of them are water insoluble, except of Kag Nasr ammonium. Al, is that a member of Kag Nasr ammonium? No. So this must be S. Another one, NH4 by 2S. Okay, again, what will be the solubility of this compound? S or AQ? First, chlorides. Is there any chloride? No. Leave this. SO4. No SO4. Leave this also. S. Kag Nasr ammonium. Yeah, mister. This is AQ because we have this compound here as the special cases. Another question. You may often ask, Mr. What if there is no even S? What to do with this? This is called the last rule. Example, if I say CaCO3, what is the solubility of this? Soluble or insoluble? Let's see. Is there any chloride? Cl? Negative? No. Leave this. SO4? No. Leave this. S alone? No. This will be the last rule. Then check for the following ions. If you see some of the following ions, NH4 and NO3, CH3COO, which is the acetate, and chlorates. Chlorates, which are ClO3 and ClO4. ClO4, hey. Negative. Chlorates, okay? If you see one of the following, the compound must be AQ. If not, it must be solid. Okay? That's how you will predict the solubility of any solid ionic compound. Okay? So let's solve or let's expect the solubility of this compound. In the exam, this compound is aqueous or solid. How do we know? First one. First rule, is there any chloride for this? No. Leave this. Second rule, SO4. Is there any SO4? No. What if there's some SO4? Okay, mister, these compounds are S, except of them will become aqueous. But it's not sulfates. How about the S compounds, sulfides? Again, very easy. Sulfate compounds, cagnacer ammonium. Okay, cagnacer ammonium compounds are aqueous, if not solid. But this is not sulfide also. So this is the last rule. Is there anything like the following ions? No. So this is solid. If you see one of the following ions in everywhere, it must be aqueous. Okay? Got it? Good. Another compound. Look at this. Ba3PO4 by 2. First rule, chlorides. Is there any chloride? No. There is no Cl here. Is there any SO4? No. Any S? No. So this is the last rule. Do we have something like this here? No. So this is solid. Another one. Look. Na2SiO3. The first one, chlorides. Is there any Cl? No. How about SO4? No. How about S? Yeah, we have it. Hey, be careful. This is Si, silicon, not S. So this is the last rule again. Is there something like this in the compound? Yeah, mister, we have sodium. This is aqueous. Okay? Let's have too many more examples. I have explained the whole rules here with the 4 single points. Again, try to have the following points in a very nice way. Redraw this like a mind mapping. Rule number 1, rule number 2, rule number 3, and rule number 4. دەستخەت شم جوانە. Okay. Yalla. I have explained the whole contents here. Let's predict the solubility of the following compounds. KCl. It's aqueous or S. Wait. First rule, chlorides. Yeah, mister, we have Cl. How was the rule of chlorides? Chlorides, only PbCl2, Hg2Cl2, and AgCl are solid. If not, it's aqueous. Yeah, this is aqueous. Mister, how about PbCl2? Wait, we have it here. Okay, I'll tell you something about this here. NaNO3, okay. Chlorides, no. Sulfates, no. S, no. So this is the last rule. We have sodium, we have NO3. This is totally soluble. يعني هبس جلاسك أي بشام بدليل لشوين خويدة تويتوا. Because for the sake of Na and NO3, it will become the most soluble compound. AQ. How about AgCl? This is the first rule. AgCl, it's a solid substance. Good. BaSO4. Mister, this is sulfate rule. Sulfates rule. How was the sulfates rule? Sirkehadi Bapir, they are solid, except will become aqueous. Is that a member of Sirkehadi Bapir? Bapir. Okay, this is S. Ca3PO4. Mister, there's no Cl, no SO4, no S. Okay, so this is the last rule. And we have none of the following ions that we explained here, hopefully you remember, in previous page. So this is solid also. Another one, chlorides. I remember the last rule you have said chlorides are aqueous. This is aqueous. Yes, look, the third rule, cagnacer ammonium. Okay, cagnacer ammonium compounds are aqueous. Okay, this is ammonium. aqueous, good. How about PbCl2? Mister, you have said if the water is hot, it's aqueous. It will become aqueous, but if it's cold, it will become solid. But how do you know if it's cold or hot? Simply, just touch it. I don't know. No, please. Look. If the question didn't say the water is hot, we assume that this is cold. Room temperature. So this is at room temperature S. Okay? FeS and Al2SO4, I'll leave them for you. Very good. Steps for solving the precipitation reaction. Stay with me. Still, I haven't explained it. Very important, or the most important point. I just tell you something. Let me take a sip of water. I'm sorry. Okay, alhamdulillah. Look, first, if I tell you why AgCl is a solid substance, but NaCl is aqueous. Why? This is because of the strength of the bond. Here, the bond is very strong. Strong. It is stronger than the attraction of water. Water molecules cannot overcome this attraction force. It will stay as it is. But here, the attraction is less. Weak. Weaker than the attraction of water, so it will become destroyed. Okay? Be careful about this. How to solve questions related to the precipitation reaction? First of all, you need to recognize the type of the question. How do we know? Once you read the question, you will see this part. Will a precipitate form, or write the net ionic equation, or the spectator ions? Immediately, this is the precipitation reaction. Okay? Will a precipitate form, the net ionic equation, and the spectator ions. Stay with me, be careful. This is the most important part of today's lesson. Okay? Look, I will open a new page. For the combination of silver nitrate, for the combination of silver nitrate and sodium chloride, will a precipitate form? First of all, I will do all the steps with this example. Okay? The first step. First step, write the double displacement reaction. The double displacement, I know, don't say, Mr. Why the second, or here we don't have to have any capital letter. This is my style of writing, please. By the way, don't mention my grammatic mistakes. I've learned my English when I was 27. I'm not like you that learned English from my childhood. Okay, I cannot bend my tongue or pronounce like the native speakers. So this is for me. This is my best. Okay. Double displacement reaction. Silver nitrate AgNO3 plus sodium chloride NaCl. How to write the double displacement reaction for this? You know how to do this. Look, silver nitrate and NaCl to become NaNO3 and plus AgCl. Look at it. Let me tell you all the possibilities about the product. It's possible to have both compounds aqueous, or one aqueous, one solid, or both compounds in a solid state. Okay? Look, the first step, write the double displacement reaction balanced and predict the solubility. It's already balanced and the solubility because it's a double displacement reaction. So both compounds at the reactant side must be aqueous, or we have a rules. About the products, NaNO3, the last rule, don't you remember? Sodium-containing compounds are always soluble. So this is aqueous. How about Ag? Mister, this is one of the exceptions, the first rule. This is a solid substance. This is called the safe, a very safe double displacement reaction. The second point, overall ionic equation. Overall ionic equation. What we have to do with the overall ionic equation? Split, destroy, separate all the ions in the aqueous compounds. This is aqueous, destroy this. It will become Ag plus. Then NO3, this is aqueous, we will have Ag and NO3. Q, AQ plus NaCl to form Na plus Cl negative, AQ, AQ. Wait for the fast way. It's not the right time to solve the question by the fast way, because first we have to follow the book, then wait. Look, then NaNO3, Na plus AQ, NO3 negative AQ plus. How about this? Since it's a solid compound, the attraction is very strong, so it will stay as it is. AgClS. Okay? As I say, because it's a solid substance, so you don't have to split this. You don't have to destroy to separate the ions in the solid substance, because you know that the attraction between the ions is very strong. Water attraction cannot overcome the attraction between the ions. This is called the overall ionic equation. Remember, what we have to do with the overall ionic equation? Separate the ions in the aqueous substances, and we need to have the solid one as it is, without changing anything. First step, write the double displacement reaction. Balance, predict the solubility. Then, write the overall ionic equation. Separate the ions in the aqueous compounds. The third step. Look, here we will have two important parts of the reaction. This part is called before the reaction. Before the reaction. And this part is called after the reaction. After the reaction. As you can see, we have some species that remains aqueous before and after the reaction. Look, example, Ag, it's aqueous before the reaction, but after the reaction, it's a solid substance. It's changing. NO3, it's aqueous, here it's aqueous. We have NO3 that is aqueous before and after the reaction. What for this? Na again, it's aqueous before and after the reaction, but Cl is changing. Okay, mister, is there some special name for the following ions that they stay throughout the solution before and after the reaction? Yeah. We call them spectator ions. What? Spectator ions. Spectator ions. The viewers. What are the spectator ions? NO3 negative and Na positive. These are the spectator ions. Okay? So what are the spectator ions? Try to memorize the definition with me right now. The spectator ions are ions that they stay throughout the solution or inside of the solution before and after the reaction. Done? Say wallah. Okay, good. با دوباره کمون. عند سعاره که دیسان لبدیات و دوباره کمون. ده ویدیو که بگرین و دوسته دقیقه سلامتی به خود دوباره دکتر. Okay? So if I remove the spectator ions, look, I will remove the spectator ions with the different color. Okay, orange. I will remove the spectator ions at both sides of the reaction, and let's have the remaining. What left? The left part is called, look, the fourth point, which is called net ionic equation, also called the best representation for the precipitation reaction. Look, try to have the second name of the net ionic equation. Net ionic equation, also called best representation for the precipitation reaction. For the precipitation reaction. Let's have the left amount. Here we have Ag plus, we have removed this part, and Cl negative AQ to form, okay, they just canceled out each other. What left here? AgCl. Solid. This is called net ionic equation, also called best representation for the precipitation reaction. Because, you know, there are some different names rather than the following names. So grab your pen and let's have the different names. The first step, we will write the double displacement. The second step, overall ionic equation. The third step, spectator ions, also called ions that do not participate in the solid formation. Okay, if the question says find the ions that do not participate in the solid formation, it means spectator ions. Or find those ions that do not appear in the net ionic equation. Again, this is the spectator ions. Find those ions that they stay throughout the solution before and after the reaction. This is the spectator ion also. So we have 4 different names. The first one, spectator ions. The first one, ions that do not appear in the net ionic equation. And the third name, ions that they do not participate in the solid formation. The fourth name, ions that they stay throughout the solution before and after the reaction. How about the net ionic equation? Net ionic equation, base representation for the solid, for the precipitation. Mister, is there something like a fast way? Yeah. The aqueous solid will become the spectator. Okay, without doing the following steps, the aqueous one will become the spectator. So Na ions of the aqueous solid will become the spectator. So Na and NO3 are the spectator ions. The solid one will become the net ionic equation. I'll show you how to do this. Look, if I solve this like or another question, then I'll tell you how to do this fastly or quicker. Another question. Will a precipitate form when solutions of ammonium sulfide? Ammonium sulfide and zinc nitrate are combined. Okay, so first step, let's have the formula for both combined compounds. The first one, ammonium sulfide. How to write the formula of ammonium sulfide? Mr. Wallah, I didn't memorize the list of the ions. Look, can you imagine? I will become very disappointed if you say this. باور بکاتە ئێستا تەڵبمانەیە پۆلی دوازێ نازانێت فۆرمولای بنووسی. هەر بەجددی دووبارەی دەکەمەوە، یعنی ئەگەر بێت و ئەچوو نەزانی ئەو ئایۆنانە بنووسی لە کاتێکەوە لە گرید 10 و گرید 11 و گرید 12 خوێندیتە، کێشە لە دەرسەکەی نییە، کێشە لە لیستەکەش نییە، کێشە لەوەیە دەبیت جنت لە قەلبی دەربکەن. خەمانای نییە تو لیستی ئەو ئایۆنانە نەزانی. پۆلی دوازەی بابی من ئێستا پێت بڵێم ناوی 50 لاعبم پێ دەڵێ، ناوی هەرچ ئەکتەری بێمانایە پێم دەڵێ، ینی لیرێکسی هەرچ گۆرانی بێمانە و ڕاپ و ئیمینەم و هەموو دەبەرە. ئێت خۆ ناتانی ینی نایترێتەکی غەریبم لۆ لەبەر بکەی، ئەمۆنیۆمەکی فەقیرم لۆ لەبەر بکەی، سۆلفایدێکی غەریبم لۆ لەبەر بکەی، بەجددی ینی کێمستری دەست بە گریانی دەکات لە دەست ئەو تەڵەبانە. So please stay with me. You have to memorize list of the ions. Simply just spend 2 days. That's all. Okay? Yeah, let's do this. Ammonium sulfide. Mr. Still, I don't know. Don't make me kill you, please. Ammonium sulfide. Look, this is ammonium sulfide. NH4 by 2S. Ammonium sulfide plus zinc nitrate. ZnNO3 by 2. First step, write the double displacement reaction. Okay, this is how to write the double displacement. My God. Okay. Yeah, the double displacement for this, NH4, NO3 plus Zelensky. Okay, then balanced, put 2 here, it will become balanced. And then predict the solubility, since it's a double displacement reaction. So both reactants must be aqueous or follow the rules. You'll find out the solubility of any of them here. NH4NO3. According to the rules, this is AQ. How about ZNS? The third rule, sulfides. Cagnacer ammonium compounds are soluble, except of them are insoluble. So this is insoluble. Good. And then the overall ionic equation. I don't write the overall ionic equation or the further steps. I will follow the fast step from now on for this. Okay, the ions of the aqueous solid will become the spectator. So the specs are NH4 and NO3 negative. These are the specs. Here, how about the net ionic equation? In order to have a safe net ionic equation, there must be a solid compound. This is the solid compound. Bring the solid to the product. Hey, be careful. Bring the solid to the product, which is ZNS, okay? And by the reactant side, there must be the ions. Look, Zn plus 2, and S negative 2, AQ. That's all. That's how you write the net ionic equation. Bring the solid to the product side, and the ions are the reactant side, but it must be balanced. It must be what? Balanced. Good. Another one. Another question. This is the same as previous question. This is also the same. Let's solve the following questions. Look at it. Write the net ionic. Okay, the net ionic equation. For the net ionic equation, we need to have a solid substance. What? Water insoluble compound. Nickel sulfide. This is nickel sulfide, NiS. How to write the net ionic equation for this? Okay, it has been solved here. This is very easy. I'm going to do this. Calcium phosphate. How to write the structure formula of calcium phosphate? Ca plus 2, phosphate is PO4 negative 3. So the compound is Ca3PO4 by 2. How to write the net ionic equation for this? Bring the compound to the product side. So we need to have the compound here, Ca3PO4 by 2. Good. And the ions here. Well, the ions which are Ca plus 2 plus PO4 negative 3, AQ, and solid. Is that enough? Yes. No, it's not enough. As I say, it must be balanced. 3 calcium, here we have 1, multiply this by 3. PO4 must be 2 here. Now, this is called the net ionic equation for the precipitation of the calcium phosphate. Another question, Yala. This is time for the second case. What if we have both products aqueous? Okay, let's do this. Will a precipitate form when solutions of magnesium sulfate and potassium nitrate are combined? Again, the formula. دەزانم لیستەکە زۆر بە جوانی لەبەر کردی. ئیتر پێویست ناکات دیسان دابەزمەوە. دەزانین لەبەر کردی. Okay. Magnesium sulfate. This is magnesium sulfate. MgSO4 plus potassium nitrate. KNO3. First, write the double displacement. It will become MgNO3 by 2 plus potassium sulfate. K2SO4. Good. And then it must be balanced. Look at it. Multiply this by 2 will become, the whole reaction will become balanced. Then identify the solubility for all of them. Again, since it's a double displacement reaction, so both reactants are AQ. How about this? Okay, Mr. One of them is AQ and the other is solid. No. All the possibilities are possible. Both, for both could be aqueous, one solid, one aqueous, or both solids. This is AQ according to the rules. This is also AQ. Okay, Mr. But this is sulfates. Wait. How was the rule of the sulfates? Sirke Haji Bapir. Is that a member of the Sirke Haji Bapir? No. So this is AQ. So there's no solid, no precipitate. Because both products are AQ, we will say no precipitate forms. No net ionic equation. That's all. Done with this kind of question. Once you get both products AQ, just say no precipitate forms, no net ionic equation. Dot. Good. How about the last case? If we have both products solid. Let me write an example for this. Look. Example for the combination of, try to have this example in somewhere, please. Write this. For the combination of barium chloride and Ag2SO4, silver sulfate. First, write the double displacement reaction. This is the double displacement reaction will become BaSO4 plus AgCl2 here for the balancing reaction. Good. Okay. These are AQ because it's a double displacement reaction. I didn't say the reactants must be AQ always, but because it's a double displacement reaction, then I will say both reactants must be AQ. But here, how about the solubility? Don't you remember sirke Haji Bapiri or sirke Hogr Bapiri? So this is solid. How about this? Chloride containing compounds are all, or most of them are soluble except of 3 of them. This is one of the exceptions. This is solid also. Oh, both products are solid. Wait. Let's write the overall ionic equation. Okay, the overall ionic equation. Well, what we have to do with the overall ionic equation? Don't you remember? The aqueous compound must be separated, must be destroyed. Okay, look. Ba plus 2 chlorides, AQ plus 2 silver cation plus SO4 negative 2 AQ to form, mister, these are solid substances. What to do? Should I split them also? No, because there's a strong attraction between the ions. So we have to keep them as themselves. Look, BaSO4 as it is, and 2AgCl as it is. Good? So how about the spectator ions? Spectator ions. Is there anything like spectator? Oh, how was the spectator ions? Ions that they stay aqueous before and after the reaction. Is there something aqueous here and here? No. Everything changes. We have everything that is changed. Okay? Everything is changed here. So there is no spectator ion. The given reaction here, this is called overall and net ionic equation. So this is used for both. Overall ionic equation equals to the net ionic equation. So let me tell you the case, the 3 cases. The first case, we have one aqueous and one solid. If we have one aqueous and one solid, I will write them here. Case 1, the products. If we have one AQ and one solid, you will say, Mr. AQ will become the spectator, and this is the net ionic equation. But if both products are AQ, then the answer is there is no net ionic equation, no precipitation. And case 3, this is the first one, this is the second one, this is the third one, okay? If both products are solid, in that case, you will say there's no spectator ions. Net ionic equation equals to the overall ionic equation. So today, you will solve anything like, will a precipitate for double displacement, overall, spectator ions, and the net ionic equation. Okay? Good. هیوادارم لی تێگەیشتە بن. هەرچەندە زۆریش ئاسانە. I'll leave the following questions for you. Okay? And next time I'll solve some questions related to this, because I will terminate today's lesson here. I will finalize today's lesson. I have explained too many things. You have to make your revision. Then for the next time, we will solve the following questions together. So stay excited. That time, I'll see you again, inshallah. Again, just stay with me. Use my videos as your private teacher. Find my booklet. I'll give you guarantee that you will get the highest mark. I promise. Okay? بس خمیتوما من. باور بکەیت پێویستیم بۆی نییە تەماشای ڤیدیۆی بکە یان نا. But باور بکە خەمیتوما. Please. Okay? So stay with my videos. Use them as your private teacher. You will get the highest mark. See you in the next video.